In this video, we will compare exponential and linear growth in a couple different contexts. So to start, I have two tables here. So I have this table right here showing the salary of job 1 each year between 2010 and 2013. Then I have another table showing the salary of job 2 each year between 2010 and 2013. So we'll use these tables to describe how each salary changed over time. So we'll start with job 1. So first of all, we'll look between 2010 and 2011, the salary increased from $32,000 to $34,400. So we can actually compute how much that salary changed by. So if we look at this, if we wanted to know how much the salary increased by, we could compute that change as $34,400 minus the $32,000. And then for each consecutive year, we could, in a similar way, compute how much the salary changed by, just by doing the final salary minus the initial salary. So let's let the computer do some of this work for us. So we'll do this salary here minus this salary up here, which is a change of $2,400. And then we notice, after the computer does some computations for us, each year from 2000 to 2013, each year that passes, the salary changes by $2,400. So from 2010 to 2011, the salary changed by $2,400. From 2011 to 2012, salary again changed by $2,400, and so on. So each year that passes, job 1 salary increases by the same amount. And therefore, this salary is following a linear growth model. Now, we could also compute the growth factor for each year. So for example, if we, from 2010 to 2011, the salary increased from $32,000 to $34,400, and so that salary became this number of times as large. We could just find that ratio of values to determine how many times as large it became. So again, let's let the computer do some of this work for us. So we'll do this value divided by our initial salary. We see that for each consecutive year, this growth factor is actually decreasing. It becomes smaller each year, which makes sense because each year that passes, the salary changes by the same amount, but the starting salary is larger and larger. Okay, let's do a similar thing for job 2, but I'll just speed this up and let the computer do some of the computations for us. Okay, so for job 2, we see that the change in the salary each year is actually increasing. So each year that passes, the salary is actually increasing by more and more. But when we compute the growth factor for each year, by computing the ratio of salary at the end of the 1-year interval to the salary at the beginning of the interval, we see that the growth factor is constantly 1.04, which means that this salary has a constant growth factor and therefore follows an exponential growth model. Okay, let's look at one last example. We have two ordered pairs, 0, 6, and 1, 4. So first we'll assume that a linear function f passes through these 2 points, so that these 2 points satisfy that linear function relationship. So let's think about this. From x equals 0 to x equals 1, that's a change of 1 unit. So that's delta x is equal to 1. And then as x varies from 0 to 1, y varies from 6 to 4, which is a change in y of 4 minus 6, which equals negative 2. And therefore, this linear function has a constant rate of change of negative 2. Anytime x changes by 1, y changes by negative 2, and therefore we have a slope or a constant rate of change of negative 2. Now, our linear function has an initial value of 6, or f of 0 equals 6. So if we want to write a function definition, we could write this as f of x equals 6 minus 2x. And when we type that in, we get a linear graph, a graph of a line passing through those 2 points. Now let's also assume that an exponential function g passes through these 2 points. Let's define that function g. So again, we can think of x varying from 0 to 1, a change of 1 unit, and then y varies from 6 to 4. So in this case, y becomes 4/6 times as large. And so 4 divided by 6 is our 1 unit growth factor. So this number right here is our 1 unit growth factor, and since y equals 6 when x equals 0, 6 is our initial value, or the value of g of 0. So if we want to define this function, we could write this as g of x equals our initial value 6 times our 1 unit growth factor raised to a power of x. So when I hit enter, we get this red function graph showing the exponential function, and that looks pretty good. It looks like the graph of an exponential function, and it passes through those 2 points.